All right, welcome back from spring break. I have missed you all a lot. We are going to, besides today will be more normal, like you were used to before spring break, but after today, we are moving into chapter 11, which will be probably the last chapter we teach you before we start reviewing for the final. And it's fairly challenging, but I think it'll be really good for you to learn. And you need to really make sure that you are in on our live lessons so that you can ask questions as you have them. We will just be giving you lessons on Wednesdays, and they will be the live lessons, and then you will have problems to do on Friday and problems to do on Monday that go with those live lessons. So again, it's really, really important that you are in our live lessons so that you can ask for help when you need it. All right? Today, though, we're going to review something that is really important that we struggle with a lot recently. Before we start, I want you to email me right now, or Miss Weldy, depending on whoever is your teacher, and tell me why this meme is funny, and I/Miss Weldy will give you 5 extra credit points on this assignment if you email me and tell me why it is funny. Me and Miss Weldy laughed a lot when we saw this on Instagram the other day, and we thought you guys should also see it. All right, so we're going to review exponents because we have forgotten how to do exponents, and that's okay, but it's quite important to not forget our exponent rules. So we're going to be able to write and evaluate algebraic expressions in exponential form using product, quotient, power of a product, power of a quotient, zero product property, and negative exponent rules. We need to know all of these, so you need to take notes, like really good notes that remind you of them. I will only be doing one example per rule so that this video isn't 45 minutes. But if you need help with any of the rules, or you don't remember them, or you need anything extra, let me know and I will help you. All right, starting with product rule. So the product rule is keep the base and add the exponents. All right. However, if we have coefficients, numbers in front of our bases, we multiply them first. So we're going to multiply 3 times 2, which is 6. And then when we look at these that have the exponents on them, we're going to keep the base, which is x, and add the exponents. 2 plus 5 is 7. So this would become 6x to the 7th power. That's the product rule. Next is the quotient rule, which is the opposite. We keep the base and subtract the exponents. Again, if I have coefficients, we need to simplify them first. So 4 divided by 12 simplifies to 1/3. Okay? Then I would keep the y and subtract 5 minus 10, which is -5. Right now, we're just going to leave it like that. However, it's more proper to write it as just one fraction, and so we would multiply straight across and we get y to the -5th over 3. And I know this isn't proper because we have the negative, but we haven't talked about that yet, so I'm going to leave it like this. Okay? All right, power rule. You keep the base and multiply the exponents. So if you look in here, there are 4 bases, 5, x, y, z. And they all have exponents, 1, 2, 3, 5. So we need to distribute this 3 to every exponent, and we're going to multiply them. So this would become 5 cubed, x to the 6th, y to the 9th, z to the 15th. And then lastly, we need to simplify 5 cubed. So 5 times 5 times 5 would be 125. X to the 6th, y to the 9th, z to the 15th. All right, that is the power rule. Alright, power of a quotient rule is the same as the power rule. We keep these bases and we multiply the exponents. And there's 4 in here, so we would get that covered up everything. But we would get 4. 3 times 3 is 9. X to the third over 2 to the 15th y cubed. Now, I know that those are giant exponents, okay? So if you have something that big, I am okay with you leaving it like that. Alright, I don't want you to have to go crazy. But if it was like 4 cubed, you can do 4 cubed, or you could do 2 to the 5th. Alright, but those would just give us really giant numbers, so we can leave our answer like this. Alright, 0 product rule. This should be the easiest one for you. Anything to the power of 0 is 1, and so yes, this looks really ugly, but realistically, this is just 1 as my answer. Anything to the power of 0 is 1, always. I want to make a note, though. If we had 3xy to the 0, okay, the 3 is on the outside of the parentheses, so this would not become 1. This would be 3 times 1, which would be 3, okay, because this would become 1, and this would stay as a 3. Alright, negative power rule. This means that nothing can be left negative. So if you have a negative, you have to move it to the opposite side of the fraction. Okay? So if I look at these just separately, if I look at the 3 that is down here right now, or up here right now, there's no negative exponent on that, so I'm going to leave it as 3. Okay? X to the negative 4th is a negative exponent, so I need to move it to the bottom and make it positive. Y is not a negative exponent, so I'm going to leave it on the top. Then I look at the bottom. 4 to the negative 2 is a negative, so I need to move it to the top, and that becomes 4 squared. W is not negative, so I keep it on the bottom. And then z to the negative 10th is negative, so I move it to the top. Okay, now, my negatives are gone, but I'm not done simplifying. I need to multiply my numbers together, and then I need to write my exponent, or my variables, from like in alphabetical order. So, at the top I have 3 and 4 squared. So 4 squared is 16. So 3 times 16 is what I would need to do next. And that's 48. So I get 48. Okay, y comes before z, so I go y, z to the 10th, over w, x to the 4th. And that is my simplified form. Okay, I just moved things from top to bottom or bottom to top if they were negative. Okay, so what about this one? If you are still thinking to yourself right now that the answer to this is x squared plus 5 squared, we have a huge problem. Okay? That is incorrect. You cannot do that anymore. Okay? Any of the problems that I just did, do any of these have pluses or minuses in them? No. Okay? So, exponent rules only work when we are multiplying our exponents and our bases and our numbers together. If you have a plus or minus within it, then you need to think about what this means. And x plus 5 squared means x plus 5 times x plus 5, which means we need to FOIL. So x times x is x squared. X times 5 is 5x. X times 5 is 5x, and 5 times 5 is 25. So this expression actually simplifies to x squared plus 10x plus 25. Okay? Stop using the power rule when there's a plus in here. You will get it wrong every single time. Okay? Now, if this was x5 squared, then yes, you can distribute it. But when there's that plus, it becomes a FOIL problem. It's a special case FOIL problem. Okay, we're going to do a couple together of all the rules together. So if I'm looking at this, we kind of follow order of operations. So that would be parentheses, exponents, multiplication, division, addition, subtraction. Okay, we kind of follow this. So we start with parentheses, and inside my parentheses here, I don't have anything I can simplify. Okay? Then we go to exponents. And yeah, I know there's exponents in all of these, but I mean this exponent is the most important. We have to do that first to kind of get rid of these parentheses. So I would distribute this 2 to everything inside the parentheses here. So 3 to the negative 8, 2 to the negative 20, and 5 to the 10th. Over, I did nothing to the bottom, so 3 squared, 2 to the negative 30th, and then 5 to the 0th power. Okay, next I do my quotient rule, which means I keep the base and I subtract the exponents. Okay, so my video cut out a little while ago and I thought I lost it all, and so I'm not exactly sure what I have taught yet, but we might as well just skip the one that I was just doing, and we're going to do this one instead. I apologize. Alright, so this one is similar to the last one, except this one has variables and not just numbers. So I'm going to distribute the 2 to everything inside the parentheses and get 3 to the negative 8, x to the negative 20, and y to the 10th. Okay, over 3 squared times x to the negative 30 times y to the 0 power. Okay, next I'm going to keep the base and subtract the exponents. So 3 to the negative 8 over 3 squared would be 3 to the negative 10th, because I'm subtracting negative 8 minus 2. Negative 20 minus negative 30 would be x to the 10th, and then y to the 10th minus y to the 0 is just y to the 10th. Okay. Then I cannot have this as a negative, and so I have to move it to the bottom of my fraction. So my final answer is x to the 10, y to the 10 over 3 to the 10th. And I know that's a lot of like 3 to the 10th is too big, so I'm not going to make you multiply it completely all the way out. Okay, the last one I want to do is this one. Whenever I have an exponent on the outside, I could take that and distribute it to everything on the inside. However, I like to simplify everything on the inside first and then put it to the 5th power if I need to. Alright, so the first thing I'm going to do is simplify the top or the bottom if I can. So if you notice right here, I can simplify this because I can do 2 to the 6th times 2 to the negative 5th, because those are the same base. So I'm going to keep those bases, and I'm going to add the exponents. So that just becomes 2 to like the first, x to the negative 10, y to the 4th over y cubed times x to the negative 10 times 2 cubed. And all that is still to the 5th power. Oh gosh, dang it. Okay. Sorry, my apologies, that just did not work. Okay, so 2 x to the negative 10, y to the 4th over y cubed times x to the negative 10 times 2 cubed, all to the 5th power. Alright, then I'm going to use my quotient rule to simplify. So I'm going to simplify the 2's first, and that would give me 2 to the negative 2 because 1 minus 3 is negative 2. Then the tens, negative 10 minus negative 10 is actually just x to the 0. And then y to the 4th minus y cubed is y, just y, to the 5th. Okay. Then I'm going to simplify everything else that I can. So 2 to the negative 2 needs to go to the bottom, and that would become 2 squared, which is 4. So I'm just going to write, sorry, I'm not actually, 2 squared. I'm going to write 2 squared. And then x to the 0 is just 1, so that goes away, and then y stays y. Okay, it's still to the 5th. So then the last thing I need to distribute that 5. And now it's a lot easier to distribute in my opinion. So my answer is y to the 5th over 2 to the 10th. I'm not going to make you simplify 2 to the 10th. Okay. If you have any questions, let me know. Sorry that it got maybe a little confusing in the middle there because I lost my connection and I didn't remember what I had done. If you have any questions, email me, please, and good luck on your worksheet. Please be on at Wednesday's conference. It's very important that you are there.